Hello, everyone. I'm going to explain in more detail the example we just did in 2.2. I'm going to work out the problem step by step, work through the whole problem in detailed steps. This is the example of composition of two functions. In this example, we have two functions, f and g. F is defined as square root of x plus 1, and g is defined as 2x plus 1. So we need to find the composition of f and g, and the open circle between f and g means composition of two functions. So according to the definition, f compose G means what? If I just start from the definition, F compose. Sorry. I can't find the composition. Okay, so let me just copy here. So F compose G of X. Okay. What is it? So by definition, F compose G, we should get another function. So we just use F compose G to denote the new function, and it has the variable X. So that's the notation. So by definition, F compose G means F of Gx. All right. So we just plug in G of X in place of the independent variable of F. Okay, so that's what I mean. Okay, so you just plug in Gx in place of X in F. Okay, so remember F is defined as square root of X plus 1. So when we mean F compose G, we actually plug in G of X in place of X in F. So remember F is square root of X plus 1. So what we do, we just plug in Gx in place of X in here. So that will give us square root of Gx plus 1, right? So let me just write down. So the square root of Gx. So that replace X in F, but then we have plus 1 inside the radical in F. All right. And then what's the next step? Then we just plug in back the expression of G into the insert. So remember, G is 2x plus 1. So that's 2x plus 1. So that's the whole thing of G. Let me just write details. So that's just the G, and then we have 1 inside, right? So that's 2x plus 1 plus 1. So at the end, it just becomes square root of 2x plus 2, isn't it? So that's pretty simple, right? And we can also do, the same way for G compose F. So why don't we just do G compose F? then you're going to see what happens. So this time we're going to do G compose F. All right. So so again, by definition, what? Okay. So G compose F means we plug in F as the variable in the function G. So so in the function notation, what we do, we just plug in F in G for X. So we still have function G, but now inside the parentheses, the variable will be f of x instead of x. So remember, the function g is 2x plus 1. So you look at the function g first, and then the variable in the g is x. We're going to replace this x by the function f. Okay, so so we get 2 times g of x, f of x, I'm sorry. As you can see, the function g is 2x plus 1. So we just replace x in g by f. So f is square root x plus 1. So then we get a 2 times f of x, or 2 times f plus 1. Okay. And the f is just the square root of x plus 1, as I just say. So the whole thing just becomes 2 times square root of x plus 1. So that's the answer. And we cannot do any simplification in this case. All right. We cannot combine a radical with a number. So you can see, when you change the order of composition of two functions, we get a different result. So in the case of wave compose G, in this example, the answer is square root 2x plus 2. And if you reverse the order of composition, you do G compose F, you get 2 times square root of x plus 1 plus 1. So they're not the same. So the order of composition of two functions is important. All right.